Hello students, in this video we are going to deal with the velocity and acceleration of the center of mass. In the last video we have studied about the position of the center of mass, and we told like this: if the body is propagating along the x axis, I can say m1 x1 plus m2 x2 divided by m1 plus m2. If it is along the y axis, I can say m1 y1 plus m2 y2 divided by m1 plus m2. Here, if the direction is not known, that means if I do not know whether the body is moving along the x axis or whether the body is moving along the y axis or z axis, if I do not know, then I will write generally like this: r. R is the position vector of the center of mass. So, to just show it as the center of mass, I will write Cm. So, RCm is equal to m1 r1 plus m2 r2 divided by m1 plus m2. This is the position vector of the center of mass in two particle system. If I do not know whether it is in the x direction or whether it is in the y direction, so I just put r. Now, m1 plus m2 can be equal to capital M, the total mass of the body. So, RCm is equal to m1 r1 plus m2 r2 divided by m. In the next step, I take this m to the LHS. So, m into RCm is equal to m1 r1 plus m2 r2. So, this is the position vector of the center of mass. Now, we are going to find the velocity of the center of mass. Expression for the velocity of center of mass. We already studied rate of change of position is called velocity. Therefore, what I am going to do is, I got the expression for the position, this one now. Now, I am going to differentiate it with time. Differentiate this with respect to time. Therefore, I can write m into drCm by dt is equal to m1 into dr1 by dt plus m2 into dr2 by dt. So, I differentiated both sides. What is dx by dt? We studied dx by dt is called velocity. So, here I just use the general term r. So, dr by dt is called velocity. So, here drCm by dt is called velocity of the center of mass. So, I will write m vcm, velocity of the center of mass, that is equal to m1 into dr1 by dt is called v1. Similarly, m2 into dr2 by dt is called v2. Velocity is a vector quantity, that is why I put vector sign. So, finally, you can write this as vcm, velocity of the center of mass, can be equal to m1 v1 plus m2 v2 divided by capital M. Capital M is m1 plus m2 in two particle system. if it is n particle system, what will you do? m1 v1 plus m2 v2 plus m3 v3 etc. mn vn divided by m1 plus m2 plus m3 etc. mn. So, I will be writing that also for n particle system. Velocity of the center of mass can be written as m1 v1 plus m2 v2 plus etc. plus mn vn divided by m1 plus m2 plus etc. mn. This is the velocity vector of the center of mass for n particle system. Now, let us see the expression for the acceleration of the center of mass. I am taking this equation, the velocities equation here. So, let me give the heading first. Expression for the acceleration of center of mass. So, as I told you, I am taking this equation, and we know rate of change of velocity is called acceleration. So, I am going to differentiate this equation with respect to time. So, m VCM is equal to m1 v1 plus m2 v2. Differentiate this with respect to time. So, m into dVCM by dt is equal to m1 into dV1 by dt plus m2 into dV2 by dt. And what is dV by dt? dV by dt is called acceleration. So, m into ACM, acceleration of the center of mass, is equal to m1 into dV1 by dt is called A1 plus m2 into A2. Therefore, I can write ACM is equal to m1 A1 plus m2 A2 divided by capital M, where capital M is m1 plus m2. Okay. Now, let me ask you one thing. What is m into A? M into A is called force. Force is mass into acceleration. So, let us see what I am going to do. For n particle system, I am going to write MACM is equal to M1 A1 plus M2 A2 plus M3 A3 plus etc. Mn An. Ma is force. So, I will be writing like this. M into ACM is called the total external force. Total external force, that is M into ACM, which is M1A1 is written as F1 plus F2 plus F3 plus etc. Fn. What does this equation tells us? Suppose there is a rigid body having n number of particles. Suppose there is a rigid body having n number of particles. There are many forces acting on all the particles of the body, and each force is given as F1 plus F2 plus F3 etc. Fn. Each force is given like that. We don't know how many particles are there. So, we don't know how many individual forces are also there. Understood? If I know how many particles are there, for example, suppose there are 10 particles, then there are 10 forces acting and we can add the vector sum. But here my problem is it consists of n particles. So, I don't know how many particles are there. So, I will not be knowing how many forces are also there. So, how will I find the total force? If I don't know the individual force, how will I find the total force? The total force can be found by take the total mass, see the acceleration of the center of mass, multiply both. So, what you have to do is find the total mass of the body, find the acceleration of the center of mass, and then multiply M and ACM. Then you will be getting the total external force. This is what we call the motion of the rigid body, total force. This is how we will find the total force of the rigid body. Okay, now let us see one more thing. Here I told you F external is equal to M into ACM in this equation. F external is equal to M into ACM. This is what we got from the above equation. Now imagine if external force acting on the body is 0. Imagine F external equal to 0. External force is 0. Then M into ACM is equal to 0. Can I ask you what is ACM? ACM can be written as dVcm by dt. Am I correct? Because dV by dt is called acceleration. So, then M into ACM is equal to 0. Mass is a constant, right? For a rigid body, mass cannot be 0. So, if mass can't be 0, so I will be writing like this: since M cannot be 0, acceleration of the center of mass is equal to 0. That means, if no external force acting on the system, the acceleration of the center of mass will be constant. Acceleration of the center of mass will be 0. The body will not be accelerating. The rigid body will not be accelerating. So, ACM is equal to 0, and here I wrote ACM is dVcm by dt. So, this implies that dVcm by dt is equal to 0. That means change in velocity. Change in the velocity of the center of mass is 0. What is the meaning of that? It means that Vcm is equal to constant. That means if no external force acts on the rigid body, the velocity of the center of mass remains constant, acceleration of the center of mass is 0, it means that the center of mass will be either at rest or it will be moving with a uniform velocity. If the body was initially in motion, the body will continue to move with the same velocity. If the body is initially at rest, it will continue to be in the state of rest itself. So, that is what I told. If external force acting on the system is 0, the velocity of the center of mass is constant. Now, what is meant by momentum of the center of mass? I just wrote VCM is equal to constant. Now, momentum of the center of mass, PCM. Momentum of the center of mass is PCM, which can be written as mass, total mass into VCM, right? If VCM is constant, then PCM is also constant. That means if no external force is acting on the center of mass, the velocity of the center of mass is constant and the momentum of the center of mass is also constant. This is called law of conservation of momentum. So, we can say like this: if there is no external force acting on the system of particles, the momentum remains constant, and this is called law of conservation of linear momentum of the center of mass. So, I will be writing like this: total momentum is equal to I can write like this: PCM is equal to P1 plus P2 plus P3 plus etc. plus Pn is equal to constant. So, this is called law of conservation of linear momentum. Okay. So, that is all in this session. Thank you.